All right. I need for everyone to choose an animal. You get to choose one and write it down in your books, which one you choose, right? It'll make the class a little bit fun, make time pass a little bit faster. Whichever animal you choose and write down, let me know which one you choose on the chat as well. And you cannot change your mind. Once you choose an animal, that's it. You're stuck with that animal. What's going to happen as we teach today? One by one, the animals will meet their doom, right? They will die off one by one. Let's see, and only one animal is going to survive. Let's see if you were lucky enough to choose the one that remains alive at the end of class, right? So let's start off with differentiation. First of all, I'm going to teach you how to differentiate a very simple expression. Now, a lot of you all might be asking, well, okay, sir is going to show me how to do this thing called differentiating, but you're probably wondering what it does in real life, okay? So for example, right, let's say you have an expression. Let's say the examiner gives you this equation. Y is equal to 4x to the power 3. So that just shows up in the exam, given to you by the examiner. And then the examiner says he wants you to differentiate it. Okay. Notice the two letters involved. It's Y and X. Well, we know by now that Y and X are variables. Whenever you differentiate Y and X, and you have to make sure Y is the subject, you get something called dy dx. This just simply means the D stands for differentiating. You are differentiating Y and you are differentiating X. To differentiate a very simple expression like this, notice the X has a power. All you have to do is throw the power in front. So the 3 will jump in front to meet what? The 4. So you will get the 3 and there will be a multiply. Because when you put the 3 over here, there will be a secret multiply between the 3 and the 4. And when you are finished throwing the power in front, you always minus 1. Always, 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 no matter what. Minus 1 from the power. So 3 minus 1 is 2. So we can simplify this. 3 by 4 is 12. And then we have x squared. That's how you differentiate a very simple expression. Now I'm going to notice what we did, right? This is a general format. In this format, look over here. The A comes like the 4 and the letter N comes like the power 3. So if you want to put this, right, in a formula form, when you find dy dx, all you have to do is throw the power in front. So you get n, a, and then what do you do with the power? You minus 1 from the power. Everyone sees the connection between this and this. This here is an actual example, and here is a general formula to represent differentiation. How much people are with me so far? All we have to do is throw the power in front and minus 1 from the power. Right. So we're going to practice a few questions and have a few little shortcuts that I'm going to show you to save time in the exam. Do you all think you all can do the first question for me? That's this one, the one in the green box. Differentiate this for me and send the answer on the chat. Let's see how much people actually understand the general formula. When we differentiate y and x, we have dy dx. We throw the power in front, so the 5 goes in front. So the 5 meets the 3. and then you minus 1 from the power. 5 minus 1 is 4. Okay, Tyler, you saw your mistake? So when you simplify this, you get dy dx is equal to 15x to the power 4. As simple as that. Try the blue one here now. Have a small trick. Notice the power is negative. Differentiate y is equal to 2x to the power minus 4. Videsh, wrong. Check it back. Check it back. All right, so let's see the small mistake. Right now, the negative powers usually give a little bit of problems. You have to throw the minus 4 in front. That's what we said. It doesn't matter if it's a negative or a positive power. The rule is you throw the power in front. So the minus 4 goes in the front. It will meet Mr. 2. But then we have the minus 1 from the power. Some of you all forgot your little algebra skills. Minus 4 minus 1 is minus 5, right? I know it's you all know come from school, so you might be a little tired, right? Minus 4 by 2 is minus 8, and then you have x to the power minus 5, or I'm just saying if. Remember in normal boring maths, right? Anytime you have a negative power, and you can throw the x underneath, and it will become a positive power. That I think that's form 3 maths. This is correct, or this one is correct. Any one will do in the exam. Let me go ahead and do the purple one now, right? I want to do this one. Notice all of these questions here. The x has a visible power. Like you can see 5 here. You can see minus 4 here. But this one here, right? It doesn't have a power. When x does not have a power, what is it understood as? That's form 3 maths. If you have a letter alone and no power, by default, what is the power? Correct, 1, okay? But nobody's going to put the 1, right? So I just say I'm doing this the long way, right? When you differentiate this, the 1 will go in front. It will meet the 7 because the 1 have to jump in front. And then you minus 1 from the power. But 1 minus 1 is 0. 1 by 7 is 7. And anything to the power 0 is 1. So you end up with what? 7. Whenever, look at this note here. Whenever it's just plain old boring x without a power, you will always just end up with the number in front. Okay? So that's a little shortcut you could use in the exam. For example, I'm not running out of space here. It's getting a little crowded. For example, if I ask you to differentiate 10x, to save time in the exam, when you differentiate 10x, since it's just x, you'll be getting what? 10. The examiner is not going to minus marks for taking a shortcut over there. Right? He's not going to minus marks. Quick question. If I have y is equal to x, when I differentiate x alone, what will I get? Any suggestions? Right. Correct answers like no Mercelin wrong, Nicola wrong. Remember, if you differentiate 10x, you're just left with the number in front, 10. Remember, x is the same thing as 1x. So when you differentiate x, you'll get what? 1. The 1 is understood, right? So that's a little trick question there, right? So I want you to take down the green one as well, because a lot of students do get that wrong in the exam, right? It's simple, but under stress, it makes such little mistakes. Okay. Right. And we're going to do this yellow one here now. Whenever you differentiate something and it has no x, it's just a number. You just always get 0. And that is what this note is saying. So if you differentiate 400 and it have no x in it, you will automatically get 0. Everyone take down everything that you need to on the screen. I'll give you a half a minute. I think it's important to know what dy dx actually means. Dy dx, it's another way of writing the word gradient. Remember in normal maths, it have this topic called y equals to mx plus c, and m stands for your gradient. Well, guess what? M and dy dx is basically the same thing. So differentiating has a lot to do with finding the gradient of equations, okay? But you're not allowed to write the word gradient, right? You have to, for add maths, you have to put dy dx, right? So make a note, dy dx is the same exact thing as gradient. It's going to get a little bit tougher. This is the second slide. Okay, so here are 3 more examples. In this one here, we'll give you a little jump start. You notice this time the x to the power is underneath. Take my advice, guys. Whenever it's a simple question and the x is underneath, don't work with the x underneath. Only try to differentiate when the x is on top. So using form 3 maths, the x to the power 3, when you throw it on top, will become x to the power minus 3. The power becomes the opposite. And only when the x is on top, then you attempt to differentiate. So now you can differentiate the pink expression. So send your answers on the chat, right? When I differentiate the pink expression when the x is on top, which is the correct way to do it, what do you get? All right. So you throw the power in front when you're differentiating. So it'll be minus 3 multiplied by 5, and you're minus 1 from the power. Minus 3 minus 1 is minus 4. So you'll get minus 15x to the power minus 4. Or if that minus 4 is bugging you, you can just throw it back underneath and you will get positive 4. Any one is correct. This one is correct or this one. The examiner is not going to care which one you put. I want everyone to try second one, the blue one, and send an answer on the chat. Let me see what you come up with. All right, so this is going to give me an excuse, and a good excuse to revise a little bit of indices from form 3. Whenever you have square root of something, let me say we have square root a. How much of you all remember that square root is the same thing as to the power a half? Remember, at some point in form 3, your teacher would have mentioned that square root is the same exact thing as to the power a half. Also, if you have 2 items being square rooted and there's a multiply in between, this is the same thing as the square root of a multiplied by the square root of b. The square root, if you have one big square root, you could separate both items and give each of them their own square root. You're allowed to do that in maths, okay? So in this question, the 6 come like the a and the x come like what? The b. So let me make this question look a little bit neater for you, and then you'll be able to differentiate it. The 6 gets its own square root, and then there's a secret multiply here, and the x gets its own what? Square root. Now, we're going to pretend we don't have a calculator, right? So leave it as the square root of 6. Leave it in surd form. And square root of x is the same thing as what? X to the power a half. And the x is on top also. You think you can differentiate it now? Throw the power in front. Nothing wrong with a half. Throw the half in front. and then minus 1 from the half, right? Let's see if you got this. You throw the power in front, so you throw the half in front. You have dy dx. So it's a half multiplied by the square root of 6. And what do we have to do with the power? Minus 1 from the power. A half minus 1 is minus a half. Now you can leave your answer like this, or, right? Or you could simplify it. Remember, a half multiplied by the square root of 6 is really the square root of 6 divided by 2. And then you could put x to the power minus a half. Or, I just saying or, I run out of space here. Or you could throw this underneath here, and it will look like this. The square root of 6, 2, and now the x, the power, will become positive a half. Or, if you want to simplify it anymore, isn't x to the power half the same thing as the square root of x? Any one of these answers will be acceptable in the exam. For those who got it wrong, right? You understand your mistake. And whenever you have things like the square root of 6, don't use your calculator, right? Leave it in surd form. The examiner will want it in surd form. For those who got it wrong, give me some feedback on the chat now, if you understand all 3 versions of the answer. Right. So the third one, right? You will notice that all the terms are completely separated from each other. He separated from him, he separated from him. So I like these types of questions because all you have to do in this case is look at him, differentiate him. Look at him, differentiate him. So you're just differentiating each section individually. That is all you are doing. But we have to make some adjustments here. Let's fix this up. Remember, try not to differentiate when the x is underneath. So the x to the power 5, now when you're throwing it on top, only the x to the power 5 goes on top. Huh? The 3 remains underneath. In school, I used to take the whole thing and throw it on top until, well, I realized I was getting the question wrong, right? So only the x goes on top. The power gets to the power minus 5. But the point is, the x is on top now, where it should be in a differentiating question. Remember, this is x to the power a half, but I don't want the x underneath. So when I throw it on top, it becomes x to the power minus a half, and then you have minus 7. Everybody is in the correct position now. Differentiate each section individually. You don't have to send your answer for this one. It will be too much a type on Zoom, but at least let me know when you are finished attempting the question. And then I will show you my answer, and then you can let me know, hey, if you got it right or wrong. When you differentiate 2x, remember, this is plain old boring x with no powers. When you differentiate that, you'll only be left with the number in front. That's a shortcut I showed you on the first slide. This one here, the minus 5 jumps in front. The minus 5 will meet the 2. So minus 5 multiplied by 2 is minus 10. We minus 1 from the power. And don't forget Mr. 3 underneath. Minus a half goes in front. So it's minus a half multiplied by 3. So you'll get, well, I'm a negative and a positive is a negative, right? So you'll get negative 3 on 2 or 1.5, anyhow you want to write it. And you minus 1 from this. Now, minus a half minus 1 is minus 1.5, right? So that is minus 3 on 2 or minus 1.5. And when you differentiate a number by itself with no x, you just get nothing. Now, you don't have to put the 0. You can just leave out the 0. How much of you all had this correct? Like, yeah, even if you had the decimal versions of it, 3 divided by 2 is 1.5. The examiner isn't going to be too picky about little things like that. If you got it wrong, check through the working, and I guarantee you, it should be easy to spot your mistake. Let's see what the next slide is about. Right. So this one here looks a little bit scary, but it's not that scary. Remember in maths, like if you have a plus b divided by 2, doesn't this mean everybody gets divided by 2? So this is really a divided by 2 plus what? B divided by 2. It's almost the same concept here. It comes like you have 3 items on top, and all of them individually get divided by x to the power 5. It's like that. The problem is everybody here is not separate. Everybody here is being held kind of like hostage by the x to the power 5. We need to separate everyone first. So before we differentiate, we have to put the question like this. We have to say x to the power 3 minus 2x squared plus 4. Well, I know x square root is x to the power half. Let's just do that one time. And everyone on top individually at the same point in time get divided by x to the power 5. You can use your indices rules to simplify these situations. When you're dividing indices, once the bases are the same, remember you minus the powers. 3 minus 5 is minus 2. So this is really x to the power minus 2. 2 minus 5 is x to the power minus 3. Plus 4.5 minus 5 is x to the power minus 4.5, or 4.5. So now each item is separated. This x item, and this x item, all of them are separated from each other. Now you can just take your time and differentiate each one of them individually. Throw the power in front, minus 1 from the power. Let's see what we get here. When we differentiate this, we get dy dx. Throw this power in front, so you get minus 2, minus 1 from the power, we get minus 3. Throw this power in front, so minus 3 gets multiplied by minus 2. So you can do that in the head, that's positive 6. And then we minus 1 from the power. Minus 4 jumps in front, minus 4.5 multiplied by positive 4, I believe that's minus 18. And then we minus 1 to get minus 5.5. How much people got that entire thing correct? No mistakes. They got each sign correct as well. Oh, okay. So we have a little cut scene here. For those who came a little late, right? You're supposed to choose one animal, and one animal is going to survive at the end of class, right? For those who chose already, who do you think the first animal is going to be to meet the Grim Reaper? Give me your thoughts on the chat there. Who you think is first to go? Some people say Terry. Some people say Tony. Let's see who is first to go. Oh, we're sorry to announce the death of Terry the Tiger. It seems a hunter got him. Anybody chose Terry by mistake? He's the first one. Oh, Lord. So if it chose Terry, sorry. I guess you won't win the game. In yesterday's class, too, most people chose Terry. All right, so for those who didn't choose Terry, the game is still on. All right, so let's try another type of question over here. This question over here, you'll notice is a little bit different from the other questions because this item here is being held hostage by the power of 7. So it's not like all the terms are separated from each other. I like to call this the hostage situation. It's where the entire thing is in brackets and you have a power on the outside. To do this type of question, right? There's a shortcut method, but I don't want to show you the shortcut method because the examiner can ask you to do it the long way. So if I only show you the short method first, you might only retain that one. I want everyone to take down this question over here. We're going to try to differentiate y is equal to 3x minus 1 all to the power 7. Tell me if you all agree with this. 2/3. Is 2/3 the same thing as 2? Like if I put a 2 here, I multiply and put a 3 here. And then I put a 5 here and a 5 here. Are these two expressions equivalent? Do they have the same value? Well, what do you all think? And I think the answer is yes. Because the 5 and the 5 will cancel out to leave you with what? 2/3. And it doesn't matter what I put here or what I put here. Once they are the same, I could put a 7 here. I just have to make sure I put a 7 here. Because the same items will cancel out. Okay? Which brings me to dy dx. Dy dx is the same thing as dy multiplied by dx. And I could put anything here and here once they are the same. I just decided to put something called du, but if I put du here, I have to put a du. And this is where this formula is this formula. It's the same exact thing. You notice the du and the du will cancel out, leaving you with dy dx. I just wanted to show you where the formula came from. I just didn't want to drop it on you and you had to just accept it. Whenever you have a hostage situation, right? You see the item in the brackets, you always call it u. So you're going to let u be equal to 3x minus 1. Everyone take down that for me. Whatever is in the brackets, always call it u. So in today's question, u is equal to 3x minus 1. Now, if u is equal to 3x minus 1, couldn't I just throw away this and replace it with the letter u? You all notice what I did? Now, it's already supposed to look like this, right? Remember, I am pretending 3x minus 1 is the letter u. But is there any need for brackets here? I don't think it's necessary to put brackets here. If it's 2 items, then you put the brackets. Everybody with me so far? All I did was replace this with u. Now, here's what we're going to do, right? Let's define dy dx. All we have to do is find dy du and then multiply it by du dx. Isn't it possible to find dy du? Because if it was y and x, I just saying if. When we differentiate it, we will get dy dx. But if the two letters are y and u, when we differentiate it, we will get dy du instead. So let's differentiate this. Don't let the letter u get to you. Throw the power in front and you minus 1 from the power to get 6. That is what we have so far. So we just found dy du. Now to find du dx. Remember, we said let the letter u be equal to 3x minus 1. So if we differentiate u and x, we will get what? Du dx. So let's differentiate this expression. When you differentiate 3x, you'll just be left with the number. When you differentiate a number without x, you will get 0. There's no need to write the 0. So to find dy dx now, we just have to take dy du and multiply it by du dx. So let's do that. Dy du is what? 7u6. And we're going to multiply it by du dx, which is 3. And when we multiply, this could easily simplify, right? We're obviously going to get what is 7 could multiply by 3. We'll get 21 u to the power what? 6. However, we want our answer to only have the letter x. Notice our answer has the letter u. We can easily resolve that. Isn't u the same thing as 3x minus 1? So anywhere we see the letter u, even at the end of the question, we could throw away the u and in brackets put what? 3x minus 1. And don't forget to put back Mr. 6. You are finished. You have just differentiated the expression. Don't worry, I have another example, right? For those who are a little bit confused on this one. By the way, the name of this rule is called the chain rule. My mistake, 1 second. The chain rule. Right? Your hair teacher mentioned that in school. All right, so let's try another example. A few people are telling me, hey, they're not 100% on this particular question. That is all right, that is all right. All right. So this one here looks a little bit more complex, right? Don't get scared by it. Quick question. Do you think we should differentiate this with all the x's underneath? Or do you think we should throw the whole thing on top first? It's not a good idea to have the x's underneath. Remember, I was saying that over and over. So what we should do, throw this entire expression on top. You'll get 1 minus 3x plus 5x squared. And the power, remember this whole thing is to the power 3. When it goes on top, it will become what? Negative 3. That is your starting point. Right, so everyone write that. Right, so let's get to u. We always let the letter u be equal to the item inside the brackets. So the item inside the brackets, it's 1 minus 3x plus 5x squared. So this entire thing inside here is the letter u, always. So if we are pretending that this is the letter u, then we can throw away this entire expression and write it as what? Y is equal to u to the power minus 3, which is what I am going to do down here. Y is equal to u to the power minus 3. Everyone who was lost before, let me know in the chat now if you're with me at least so far, right? Let me know if you're with me so far. So we have two expressions, one with the letter u and x's, and the other one with y and the letter u. If we differentiate y and u, we will get what? dy du. Remember, to find dy dx, we need to find the expression for dy du and then multiply it by du dx. So I'm handling this one first. When I differentiate this expression, the minus 3 goes in front and we minus 1 from the power. So that's the expression for dy du. Now we need an expression for du dx. Let's start. I'm looking at all this. Du dx. That's this expression. We have a u and an x. So let's differentiate that. When we differentiate 1, we will get 0. When we differentiate minus 3x, we will get minus 3. And when we differentiate this, we will get positive 10x to the power 1. But there's no need to write the 1 because the 1 is understood. Throw the 2 in front, minus 1 from the power. Take down up to there. All right. So what we're going to do now, to find dy dx, we have to take the expression for what? Dy du. Where's dy du? Look, dy du down here. Minus 3u to the power minus 4. And multiply it by du dx, which is minus 3 plus 10x. Now, you have to put this in brackets, right? Because we want to multiply the whole thing by this expression. But the problem is, right? Well, we could simplify this a little bit, right? Remember, everyone in the brackets here is going to get multiplied by what? The minus 3, right? Because you can at least do that, right? So the minus 3 by the minus 3 is positive 9. And the minus 3 by the minus 10x is minus 30x. And who we have waiting here? U to the power minus 4. Right? Always try to simplify it as much as you can for the example. Now, you notice our answer has the letter U. We don't want our final answer to have the letter U. So at the end of the question, remember we were pretending that U was this expression. So at the end of the question, throw away the U and put 1 minus 3x plus 5x squared to the power minus 4. That's your final answer. Don't leave your final answer with the letter U. Make sure your final answer only has the x's. For those who were lost, we better now? Or are we getting closer to understand? Move on. All right. So this one looks a little bit scary, but don't worry about it. Let's fix this one up first. So we want to differentiate this. So this is the same thing as 4. Nobody likes a square root. This is 2x to the power 3 plus 7 to the power half. But the problem is this whole thing is underneath. So we need to throw this whole thing on top. So the positive a half will become what? Minus a half. And you will end up with this. All right. Once you get it to look like this, whoever is in the brackets is the letter U. So you are going to try this one for me. Even if I get it wrong, just try. Just let me give you one little small step. The letter U is equal to 2x to the power 3 plus 7. So that's a little jump start there. Let me know when you are finished. So if we replace this middle section with the letter U, we will get 4u 2 to the power minus a half. So we're going to find two things. We're going to try to find dy du, which should be real easy. We have to differentiate the y and u expression. So we throw this power in front. The minus half gets multiplied by 4. 4 multiplied by minus a half is minus 2. And we minus 1 from this power. So you get minus 1.5 or minus 1.5. Great. How much people had that at least, right? You had the minus sign here also. You can't forget the minus sign, of course. I know some people will have minus the 1 wrong, right? Right. Du dx, that's this expression. You will get 6x squared, right? And when you differentiate the 7, you will get 0. So it's just 6x squared here. We have to put the two of them together now. dy du, where is that? That's minus 2u to the power minus 1.5 multiplied by du dx. That's this guy here. Let's simplify this before we replace the u. Minus 2 can multiply by the 6, so we get minus 12. You can put the x squared here and the u last. It doesn't matter if you have it the other way around. You can have the u first. It really doesn't matter, right? And now the letter u, we can throw it away and replace it with what? That's not what. Get different color here. 2x to the power 3 plus 7 to minus 1.5. How much people got this correct, right? You can have the x squared part last also. You don't have to have the x squared in the middle. Look for your mistakes. Look for your mistakes. Right, so once again, this is a chain rule. Oh, we're back to a little cut scene here. Who do you all think is next to go? Terry the Tiger is already up in heaven, hopefully. Who is next on the list here? Who? What do you all think? Somebody said Alan is next to go. Alan the alligator. Laura, some people are saying Freddie. Somebody say Farina needs to go. Let's see who meets the Grim Reaper. We're sorry to announce the death of Farina the fish. Seems that some piranhas got to her. Bye-bye, Farina. All right, anybody picked Farina? If you picked Farina, I guess you're out of the game. So. All right, so I'm going to show you the shortcuts, right? Remember we did this question earlier today, but we did it using the, how you call it, the chain rule. The shortcut is this. Whenever you have a brackets until like to the power 7, when you're differentiating, right? And I will only use this method if the examiner didn't tell me which method to use, right? Like he left it up to me. All you have to do is throw the power in front as usual. So you throw the 7 in front, right? And you minus 1 from the power. As normal. So you'll get 6 over here. But there's one additional rule. You have to differentiate whatever is in the brackets, and whatever you get, throw it outside. So if you differentiate this, and you should be able to do this in your head now, when you differentiate 3x minus 1, won't you just get 3? Because the 1 will give you nothing. So when you differentiate this, you will get 3. Whatever you get, throw it outside as well. And when you do that, you'll get 21, 3x minus 1 to the power 6. Can you all confirm if this is the same answer we got when we did it the long way? Look back in the notes. Is it the same answer? All you're going to do is throw the power in front, differentiate whatever is in the brackets, and throw that outside as well. Try this one here using the shortcut method, right? Y is equal to 1 minus x to the power 10. Try that one using the shortcut method. Remember, in the shortcut method, we throw in the power in front. So I think the majority of people getting that correct. So the 10 going in front, you write back this expression, you minus 1 from the power. But then you have to differentiate whatever is in the brackets. Remember, this is 1 minus x. Isn't this the same thing as 1 minus 1x? When you differentiate this, won't you get minus 1? A few people put positive 1. Remember, this is minus 1 hovering next to the x. So the minus 1 goes outside. It's a slight trick the examiner likes to play on you, right? So you get in minus 10. Some people put in positive 10 by mistake. Right? For those who got it wrong, you understand the trick? Minus x is the same thing as minus 1x. No examiner is going to put in that minus 1 for you. You have to know that. So let's move on. All right. So I want you all to try this one using the shortcut method, right? That square root is a real humbug. So we'll put the 5 minus 4x to the power minus 3. This whole thing is to the power a half. So when we're differentiating here, throw the power in front, so you get a little half here, right? I just put in a little space here, right? Over here, we have 5 minus 4x to the power minus 3. We minus 1 from the power, so we get minus a half. But we also have to differentiate whatever is in the brackets. Now, inside the brackets, we have 5 minus 4x to the power minus 3. If I differentiate this in my head, when I differentiate the 5, I will get 0, so I don't really care about the 5. When I differentiate this, the minus 3 jumps in front, so you get positive 12, and you minus 1 from the power to get minus 4, right? So over here, when you differentiate this, you have to throw it outside as well. So you get multiplied by 12x to the power minus 4. Obviously, you can't leave it like that. A half of 12 is what? 6. I think you should simplify it for the exam. How much people got this answer? Look at it and make sure you have all the signs and everything correct as well. What happened there? All right, who do you all think is next here? What's your guess? What's your guess? One person said Laura is next to go. A lot of people have a vendetta against Freddie. And no one seems to like Alan, the alligator. All right, let's see what's going on. Let's see who gets it. Oh no, it seems it's Laura. She got squashed while wandering too close to our campsite. Bye-bye, Laura. Anybody chose Laura? If so, game over. Right, so we're going to move on to differentiating some trigonometry functions. This is going to be super, super easy. So let's take down that little subtopic there. All right. All right. So this is going to be real simple, right? When you differentiate sine, you get cos. When you differentiate cos x, you get minus sine x. Let me just explain these here. We might need a little example to go with these over here, right? If I ask you to differentiate, let me say I want you to differentiate sine 3x plus 2. When you differentiate this, when you differentiate sine, but it's not sine x, it's sine with a brackets and you have a few items inside here. What you need to know is that when you differentiate sine, you get cosine. So you put your cosine. Then you write back the same exact thing in the brackets. And then whoever is touching the x goes outside. So since the number 3 is touching the x, he will go outside as well. That is what this formula is trying to say. And similarly, if you differentiate cosine with some items in brackets, when you differentiate cosine, you get minus sine. You write back the same exact thing in the brackets. And whoever is touching x also goes outside. Right, so you have to memorize these formulas by heart. I don't think they come on the formula sheet. Right. Oh, well, I have, for all the questions we're doing, I have the formulas next on the side here. So for this one here, when you differentiate cos 2x, well, when you differentiate cosine, look over here. Cosine, you get minus sine. But it's more this formula you're looking at, right? So when you differentiate this, dy dx, you will get minus sine 2x, but whoever is touching the x goes outside as well. As simple as that. Okay? So that's the answer for that one using this formula. I would like you all to try the purple one. I want to point out something. Some people are interpreting this as sine 3x plus 4, but there's a big difference. I mean, if this was in brackets, that means this whole thing would belong to the sine, like in this case here. But you notice this 4 is not really affiliated with the 3x. He's completely what? Separated from that 3x. So when you're differentiating this, dy dx, okay? When the 4 is by himself. When you differentiate the 4, you're going to get 0, so you don't have to write that. But when you differentiate the sine x, you will get what? 3 cos 3x. For those who got it wrong, you understand it now? That there's a big difference between the whole item being in brackets and coming after the sine. To the next slide here. All right, so try these here. You notice these one, they have the brackets, right? It makes a big difference where the brackets are located. But let's work out the purple, not the purple one, the green one. When you differentiate this, you're going to get dy dx. When you differentiate sine, you get positive cosine. You write back the same exact thing in the brackets. And whoever is touching the x goes outside. But it had a 3 outside here as well. So the 5 is going to meet the 3 to get 15. 5 multiplied by 3 is 15. How much of you all got that one correct? I see some of you all typed the answer, so great. But for those who didn't, give me some feedback, please. Now, the next one, you gotta be a little careful. Because when you differentiate cosine, you get minus sine. You're seeing it here, right? So you not only have cosine, it starts off with a negative. So when you differentiate this, the minus from here is going to merge with this minus to give you a positive. So you have to be careful about that. Also, this 3x is separated, but when you differentiate 3x, you'll just be left with the number 3. So let's see if we have the correct answer here. dy dx When you differentiate the cosine, you get minus sign, so you get positive sign. You write back the same exact thing in the brackets. Well, whoever is touching the x, which is 2, goes outside, and the 2 will meet the 4 to give you positive 8. And when you differentiate 3x, so he's a loner, you just get 3. How much have you all had that, Sarah? You fell for the trick, right? Because when you differentiate cosine, you get minus sign. So the 2 minus signs will touch to give you a positive. All of these are little tricks that the examiner plays on you in the exam, right? All right. So let's try this one here. This one here will be forced to use the chain rule. So I just want to do one of these here before I discuss the homework. Remember, this here is the same thing as what? Y is equal to 4x minus cos 2x, and the whole thing is being held hostage by to the power half. I don't want to use the shortcut method for this. I want to use the chain rule. So we're focusing up here. We're going to let u be the item inside the brackets. What's inside the brackets? 4x minus cos 2x. So now we can rewrite this. We can rewrite this equation, but replace this with the letter u. So we'll get y is equal to u to the power a half. Do you all think you all can finish this question for me? Right? You have a little jump start on the question. All right, let's do a little piece here. So we have an expression with y and u. So when you differentiate that, you will get dy du. The half goes in front, and you minus 1 from the half to get minus a half. To find du dx, we have to differentiate this expression. When you differentiate 4x, you just get 4. And when you differentiate cosine, you get minus sign. But the 2 also goes in front. So the 2 minus signs are going to touch. So you'll get positive 2, not cos, sorry, sine, and you have to write back the 2x. How much people have up to there? But you also have here as positive. You did not fall for the trick. Right. And now you just have to put the 2 of them together, right? We take dy du, which is a half u minus a half, and we multiply it by du dx. We should probably put this in brackets because it's so much items. Right? Now, everybody here is going to get multiplied by what? The half, right? So I guess we could probably put the brackets in front and just multiply everyone inside here. Now, when you're multiplying everyone by a half, only the 4 and the 2 get multiplied by a half. This 2x does not get multiplied by the half. He's immune from that multiplication. So you'll get 2 plus sine 2x u to the power minus a half. Number half of 4 is 2. A half of 2 is 1, but I did not bother to put the 1. And I'm going to throw away the letter u and replace it with 4x minus cos 2x. And that whole thing is to the power minus a half. Right? I know I kind of rushed the question, but we're running out of time and I needed to discuss the homework as well.